In today's video, I want to talk about the major differences between the early AI agents and the modern language agents, and I will focusing on how they interact with the environment, and I will explain this by using a detailed and concrete example. So let's get started. Earlier AI agents were built to operate in a very specific controlled environment. For instance, consider we have an AI system built to control a robotic vacuum cleaner. So this AI system is designed for a well-defined environment, which is the home. It can interact with objects like walls, furniture, or obstacles on the floor. The robot's AI has hard-coded rules, like if the robot detects an obstacle, then turn, and if the battery level is low, then navigate back to the charging dock. So the environment is simplified, and the robot doesn't need to understand the complex external data sources or communicate with any other systems beyond its built-in sensors. So the robots can only operate within the limits of its programming, and if the environment becomes more complex, for example, if the house layout changes drastically, then this AI could be struggle unless we reprogram it for those specific scenarios. Compare that to a modern language agent. This type of AI can interact with multiple environments at once and understanding diverse formats and perform reasoning without being pre-programmed for each specific environment. So let's go through a concrete example, which is calculating how your weekly average sleep time has changed over the past 6 months. For instance, part of data that comes from a fitness tracker, which is stored in a cloud database accessible via an API that returns results in a JSON format, and another part of data is stored in an Excel file that is manually updated during a vacation, and it is stored on your personal computer. And some of the supplementary data might be in a sleep tracking app that uses a different format like XML. So interacting with the heterogeneous environment, right, your sleep data is stored in different formats and different places. A modern language agent can interact with all of these environments autonomously. First, the agent figures out it needs to retrieve data from the fitness tracker's database, so it just sends a query through an API by using a JSON format to get the raw sleep data, and then it locates and opens the Excel file on your computer to fetch more sleep data by using different tools such as an Excel parser. And if there's additional data in XML format from the sleep tracking app, the agent would be able to retrieve and parse this data as well without being specifically programmed for each format, And then it's reconciling different formats. The language agents doesn't require all data sources to be in the same format like JSON or XML. Instead, it can understand how to transform data from each format into something it can work with. For example, the JSON data from the fitness tracker might be structured as nested objects, right? While the Excel file is tabular, and the XML file may be hierarchical elements. So this agent reconciles these differences without needing hard-coded instructions. So these are the autonomous interactions with different environments. And then let's talk about orchestrating reasoning step. So after we gathering data from all these sources, the agent needs to calculate weekly average sleep times, right? So it recognizes that this involves coding logical and may decide to write and execute a Python program. So the agent writes code to first load the collected data and then clean and normalize the data. For example, it may convert in timestamps to a common format like that. and then it calculates the weekly averages for the past 6 months, and then presenting the result, which is finally the language agent can visualize the results. It may choose a plot a graph by using Python's matplot library or input data into Excel to generate charts. So anyway, the agent just decides how best to present the result, which is adjusting to the tools at hand.